Okay, everybody, this lesson is proving lines are parallel. In the last lesson, the lines were parallel, and we had all those things happen. And so this lesson is very similar, except now we're proving that the lines are parallel. So if all those things that happened in the last lesson, if they happen here, then the lines are parallel. I know you're thinking, what the heck is this guy talking about? You'll see it's very similar. So a converse, you guys, a converse of an if-then statement. So let's say I had if P then Q is formed. It's just formed by switching the P and the Q part. So it becomes if Q then P. And you're thinking, what? Okay, so for example, you guys, here's an if-then statement. If I live in Sacramento, then I live in California. Now, as far as I know, that's true, you guys. So someone told me there's a Sacramento in Kentucky or something like that. I don't know. But as far as I know, if I live in Sacramento, then I live in California. Okay, the converse would be just flip them around. So it would be if I live in California, then I live in Sacramento. And that's not necessarily true. I could live in all kinds of places in California. So anyways, that's an example of a converse. Okay. You'll see how I tie that into that in just a second. So here we go. We got lines L and M are parallel. So this is from the last lesson. Okay, so when the lines are parallel, all the stuff happens. So it says 6 and blank are supplementary, same-sided interior angles. Okay, so same-sided, these guys are on the same side and they're inside the parallel line. So 6 and 3 are supplementary, okay? 4 and blank are alternate interior angles, okay, and they're congruent. 4 and 6, they're on alternating sides of the transversal, and they're congruent. Now this is because these lines are parallel right there. So 4 and 6. 3 and blank are corresponding angles, and they're congruent. So it says 3 is congruent to blank because of corresponding angles. Corresponding angles are, if I slid this line down right on top of this line right here, this angle slides right down on top of this angle. So those are the corresponding angles. So 3 and 7. Okay, is this sort of ringing a bell from the last one? 8 and blank are alternate exteriors. Exteriors means outside. So here's 8. So what's the alternating? The alternating on the transversal would be 2. And they're congruent to each other, okay? So 8 is congruent to 2. 7 is congruent to blank because of vertical angles. Vertical angles are opposite each other. These guys are congruent no matter what. I don't care if lines are parallel or not. They don't have to be parallel for vertical angles to be congruent. So 7 and 5 are congruent no matter what. Vertical angles are always congruent. 4 and 6 are supplementary. Oops, I say 4 and 6. 4 because they form a linear pair. So what forms a straight line with angle 4? Well, 3 does, so does 1. So straight line, see how 1 and 4 give us this straight line, and how 3 and 4 gives us this straight line right there. So as long as they make a straight line, then they are called a linear pair. So it could be 1 or 3 on that. Okay. Now I'm in the office, you guys, so you're going to hear some people talking. It's my prep period. Someone teaches in my classroom on my prep period, so here I am down in the office. Anyways, all right, now you guys, the trick, and I think I said it in the last lesson, is if the lines are parallel, the angles that look congruent are, the angles that don't look congruent are supplementary. It means 180. So let's look at 6 and 1. 1 is an obtuse angle. 6 is an acute angle. So they're not congruent, so they must be supplementary. Okay, so if I know any one of these angles, I know all of them as long as the lines are parallel. Okay, if the lines aren't parallel, then the math's magic stuff doesn't happen. I still know that 1 and 3 are congruent, and 1 and 4 are supplementary, and 1 and 2 are supplementary, but I don't know anything about the bottom angles unless the lines are parallel. All right, so here we go. So the converse of our theorems, postulates in the last lesson are also true. So this says, for example, same picture, so you don't have to redraw the picture unless you want to. So it's just to say same picture. So in the if two lines are cut by transversal and any of this following good stuff happens, then the lines are parallel. So here we go. If the same-sided interior angles are supplementary, then the lines are parallel. So if I can show that 4 and 5 are supplementary, or 3 and 6 are supplementary, then the lines are parallel. Okay? Remember, the last lesson was if the lines are parallel, then the same-sided are supplementary. This lesson saying if the same-sided interiors are supplementary, then the lines are parallel. So they're the converses. Okay? All right, so this next one says if the alternate interior angles are congruent, so if we can show that 4 is congruent to 6 or 3 is congruent to 5, then the lines are parallel. Okay, if alternate exterior angles are congruent, like 1 and 7, 2 and 6, if we can show that those are congruent, then the lines are parallel. Okay, and then corresponding angles. If corresponding angles are congruent, then the lines are parallel. Correspondings are when the lines come together, the ones that lay right on top, like 2 and 6, if they're congruent, or 3 and 7, or 4 and 8, or 1 and 5. If we can show that any pair of those are congruent, any one pair, then those lines are parallel. Okay, now these are all called converses, and you're thinking, wait, I didn't see that. Well, look, this is just the converse of the same-sided interior angles theorem. This one is the converse of the alternate interior angles theorem. Okay, the alternate interior angles theorem said if the lines are parallel, then alternate interior angles are congruent. This says if alternate interior angles are congruent, then the lines are parallel. Okay, this is the converse of the alternate exterior angles. Okay, and the converse of the corresponding angles theorem. Okay, now the difference between a theorem and a postulate, you guys, is theorems are things that are proven. Postulates are statements that we assume to be true without a proof. Theorems are proven. We will only prove about 5% of them, if that. We just don't have enough time or knowledge to prove them all. But if it says theorem, somebody proved it. Okay, so the parallel postulate. So this is a statement that is accepted to be true without proof. So through a point, here's a point that's not on a line right there. Through that point, there is a line, only one line that's parallel to that given line L. Okay, and we're going to try and do this. Now, my kids haven't done constructions yet, so they don't have to do this. So if you're in my class, we haven't done it yet, but I don't know where you are in here. So we're going to go ahead and try, and I've been a while since I've done this with this here. So anyways, let's see if I can help you with this if you're doing constructions in your class. So let's just pick a point on line L and use your straight edge to draw a line through Q. So I'm going to put a point right over here, okay, and then we'll pick up my straight edge, and I'm just going to draw a line right through those 2 points right there. I think I missed them just a little bit, but there it is right there, okay. And then the second thing is we're going to use our compass to copy the angle Q. Okay, so I should have this here first. Let's see if I can take that back. Let me insert a page. Let's go back. Okay, and then let's go here. Let me copy this. So here we are. So we are going to, so now I'm right here. Okay, so next step is to use a compass to copy the angle Q at point P. So this is assuming you guys have copied angles before. So if you haven't, just hold on for a second. This is how you copy an angle. Let's see if I can do it correctly here. So I want to go down here. So I'm going to make this arc right here. Let me get a smaller little piece right there. Okay, so we're going to make this arc right here, okay, right there, and I'm going to take that compass opening and do the same thing right there. Okay, so so I got to make the same compass opening. Okay, now this is assuming you've done this before. If you haven't, you have no idea what I'm doing. All right, so the next step to copying an angle is to put pointy right there. Actually, I'm going to put pointy up here, you guys. I'm going to put pointy right there, and I'm going to rotate my pencil down so it crosses over right there. So I got to close it up and then cross it over, and just I'm going to make a little arc mark. Let's see if I can get it. Okay, so there it is. Right, let me open it just a little bit more. Okay, so I'm going to take that and make that arc right there. Perfect. And then I'm going to take whatever compass that is and go up here, put pointy right there, and then I'm going to construct it again right there. Okay, so now what we're going to do is pick up a straight edge. Let me move that out of the way. And where these two arcs intersect, I'm going to connect it to point P. And so what we've done is we've copied the angle there. And since we've copied the angle, those are called corresponding angles. And since those corresponding angles are congruent because we just copied them from our copying an angles construction, they are congruent. Okay, now if you're in my class, you can just put section E was a construction, and we skipped that. All right, My kids know that. Okay, so same picture as before. Use the given angle relationship to tell whether the lines are parallel and explain. Okay, so here we got 1, 2, 3, 4. Okay, so if 3 and 5 are congruent, okay, let's look at 3 and 5. Okay, if they're congruent, those are alternate interior angles, and if they're congruent, then yes, the lines are parallel. Alternate interior angles theorem, okay, or the converse of it. Sorry, you can just write alternate interior angles. If the lines are parallel, if the alternate interior angles are congruent, then the lines are parallel. Okay, 5 and 6 are supplementary. Well, 5 and 6 are a linear pair. They're supplementary no matter what. They don't have to be parallel or not. So I'm going to say no. They're supplementary no matter what. Okay, now 5 and 4 were supplementary. Like this one says, 4 and 5 are supplementary. These are same-sided interior angles. And if they're supplementary, yes, then the lines are parallel. Okay, same-sided interior angles. All right, so this says 4 and 8. Okay, 4 and 8. Okay, 4 and 8 are corresponding angles. So if they're congruent, then I can say, yes, those lines are parallel. So 4 is x plus 20, 8 is 2x plus 5. Let's plug in 15. 15 plus 20 is 35. 2 times 15 is 30. 30 plus 5 is 35. So since they're both equal to 35, then yes, because of the corresponding angles theorem right there. So the lines would be parallel. Okay, one more piece. All right, so what must be true about the angles to make L parallel to M? Name the postulate or theorem. Okay, all right, what must be true about angles 7 and 3? 7 and 3, to make these lines parallel, they must be congruent because they're corresponding angles. Okay, all right, how about 6 and 3? 6 and 3, they must be supplementary because they're same-sided interior angles to make those lines parallel. All right, so this says, suppose angle 4 equals 3x plus 5. Here's 4. And angle 5 equals x plus 95, where x is 20. Are the lines parallel? Well, they're parallel if they equal, add up to 180. So we're going to plug in x equals 20 here. So 3 times 20 is 60, plus 5 is 65. We're going to plug in 20 here. 20 plus 95 is 115. Okay, so 65 and 115 do add up to 180. So yes, because the same-sided interior angles are supplementary. Okay, this says, suppose that the measure of angle, let's see, 7. I think this is supposed to say the measure of angle 3. Okay, so I'm pretty sure that's supposed to be a big fat 3 there. Let's put that in there. Okay, it's going to be hard for me to draw this with my finger. There's supposed to be an angle 3 right there. Suppose the measure of angle 3 equals 4x plus 5, and 7 equals 80 minus x, so where x is 15, so 3 and 7, these guys are corresponding angles. Now, they're corresponding angles no matter what. Now, if they're equal, then the lines are parallel. So let's plug in 15 right here. 4 times 15 is 60. 60 plus 12 is 72. Okay, so over here, when we plug in 15, 80 minus 15 is 65. I'm going to say no because they're not congruent to each other. They got to be congruent to each other to make those lines parallel. Okay, if you are in my class, and I think the rest of our groovy class, you're going to get a worksheet that says something like that. Okay, take care.